Hello students, welcome back to the classroom point. In our today's class, we shall discuss one of the easiest tool that helps in solving the stoichiometry questions, that is POAC, Principle of Atom Conservation. And actually this is not a theory, but this helps us in solving the questions. So let's begin the concept. POAC. It is called as Principle of Atom Conservation. So how to apply this principle of atom conservation? Basically, POAC helps in solving the stoichiometry questions in an easy manner, but only thing we must know is we must have an idea about the complete reactants and the products. Only writing the half of the reaction, we don't get the solution using this POAC. Only if you know the complete reaction, then POAC can be applied. But only the use of this POAC is without balancing the chemical equation we can solve. That is the only use. Otherwise, mole concept and this concept also similar. But in this concept, not necessary to balance. So that once atoms are conserved, we can solve the questions. Let's begin this one. How this is helpful. First of all, no need to balance the chemical equation. Second one, complete reaction has to be written. So these things are the main things that we use in the POAC. And what actually POAC stands for? What is the atom conservation? We know that according to the Dalton's law, Dalton's atomic theory, atom can neither be created nor be destroyed. That means atoms are conserved. What is the meaning of atoms are conserved? That means whatever the number of atoms of a particular element present in the reactant will transform completely into the products. So these products may be in the single product or various number of the products depending on the type of the reaction. So that's why atoms are conserved here. The number of atoms of a particular element do not change in a chemical reaction. So this is the main thing here. Let us apply POAC by taking some examples here. Now imagine calcium carbonate on decomposition converts into the calcium oxide and carbon dioxide. So here, if you consider the calcium atoms are conserved, so let us take the Ca is conserved. So we are going to write down the formula with respect to the calcium. So wherever calcium is present, for all the reactants and products, we apply this concept. So here, how many calcium atoms are present in a particular single molecule? Only one calcium is there. So 1 into number of moles of CaCO3, number of moles of CaCO3 is equals to, and a calcium is present on the other side here. So that here also only one calcium is present. See that, as I said, not necessary to balance the chemical equation. So the number of atoms what we are considering must be taken from the single molecule, not from the stoichiometric coefficient, and not stoichiometric coefficients are not required also. So here one calcium is present, 1 into number of moles of the calcium oxide. Now what happens if carbon is conserved? So carbon is conserved. If carbon is conserved, here one carbon atom is there. So 1 into number of moles of calcium carbonate is equals to, here one carbon is present, so 1 into number of moles of the carbon dioxide. Now let us take here. What about if we consider the oxygen? See here, 3 oxygen atoms are present in the single molecule of the calcium carbonate. So here we write down we can write down that 3 into number of moles of the calcium carbonate is equals to. Now oxygen is present in the both cases. So both are to be considered. So here 1 oxygen atom is present. So that 1 into number of moles of the calcium oxide plus here 2 oxygen atoms are present, so that 2 into number of moles of the carbon dioxide. This is what I said. Simply without writing the calcium oxide, if you write down only carbon dioxide, we get the wrong answer if oxygen atoms are conserved. So that is the reason why we must know the complete reaction to apply the POAC, and only thing is not necessary to balance the equation. So let us see some questions now. Let us solve some questions now. The given question is 1.225 grams of KClO3 on strong heating gives oxygen gas. What is the volume of the oxygen released? Molecular mass of the KClO3 is 122.5 grams per mole. So let us see the solution for this question. Basically they said KClO3 on strong heating, it decomposed into the KCl plus O2, oxygen gas is given. And they are asking about the oxygen gas, so that we have to keep the oxygen conserved. So oxygen conserved means here how many oxygen atoms are there? 3 oxygen atoms are there. So that 3 into number of moles of KClO3 is equals to here 2 oxygen atoms are there. 2 into number of moles of the oxygen. So here 3 into number of moles means weight by molecular weight. Weight of the KClO3 is given 1.225 grams and molecular mass of the KClO3 is 122.5 grams is equals to 2 into volume of the oxygen they are asking. Number of moles means volume by STP volume 22.4. So that here we can take that volume of the oxygen that to be calculated divided by 22.4 liters. So here volume of the oxygen is equals to, send all these values the other side. So 3 into 1.225 divided by 122.5 into 22.4 divided by 2. So it goes 1, 2, 3, it goes almost 10 power minus 2 times 1.225, and here it goes 11.2 times, so it is 33.6. So volume of the oxygen is equals to 33.6 into 10 power minus 2 liters. So like this we can solve. So this helps only in a short way to solve the questions without balancing, but we must know the complete equation, means total number of the reactants and products, because atoms are conserved. Now let us see another question. 1.44 grams of titanium reacts with excess of oxygen gives titanium 1.440. That means oxygen, it is a non-stoichiometric compound. Find the amount of Ti 1.44O. So here titanium 48 atomic mass is given and its molecular mass is 85.12 grams per mole. So let us try to solve this question. They are saying that titanium reacts with some excess amount of the oxygen, finally giving the titanium 1.44O. So here in both cases titanium is common, so that titanium atom is conserved. So here how many titanium atoms are present? So titanium is conserved. So 1 titanium is there, 1 into number of moles of titanium is equals to, here 1.44 are there. So 1.44 into number of moles of Ti 1.44O. So here number of moles of the titanium means mass given atomic mass. So mass 1.44 divided by atomic mass is 48 is equals to 1.44 into number of moles means weight by molecular mass. So they are asking us to calculate the weight. So that weight of the titanium 1.44O divided by its molecular mass is 85.12. So we can calculate that. weight of titanium 1.440 is equals to, then cross multiplications, so that it is equals to 85.12 divided by, so is the mass of the titanium non-stoichiometric compound oxide. So the next question, 0.60 grams of silver salt of tribasic organic acid. They said organic acid, but molecular formula is not given. Let us consider the organic acid A, and they said the tribasic acid, so that it is able to release the 3H plus ions. So that on dissociation it is able to release the 3H plus ions plus A3 minus. This is the dissociation one. Organic acid was reduced to the 0.37 grams of pure silver. See here, in this silver is present, here we have taken the tribasic acid. Then if it is combining with the silver, what could be the formula of its silver salt? We know that silver valency is equals to Ag plus, and hydrogen valence is also H plus. That means number of H plus ions equals to number of Ag plus ions. So the formula of the silver salt of the tribasic acid is Ag3A. So this was reduced to pure silver. Pure silver. Then they're asking, find the molecular weight of this particular compound. This compound they're asking, find the molecular weight of the acid, not the salt. So this we have to calculate it. Now let us see here, silver is conserved because both side silver is present, so that I can write down that silver is conserved. So if you want to conserve any particular atom, it has to be present on the both sides, reactant as well as in the product which you want to calculate. So here 3 moles of silver is present. So 3 into number of moles of Ag3A is equals to 1 silver, 1 into number of moles of this silver. So here 3 into number of moles means weight by molecular mass. So weight is given, that is 0.607. Molecular mass we don't know, so that I can write down molecular mass of the organic silver salt of the organic acid Ag3A is equals to number of moles, weight by atomic mass. Weight is given here 0.37 grams. Atomic mass of the silver is 108. So now we can calculate the molecular weight of the silver salt of the carboxylate ion, carboxylic salt, into cross multiplication 3 into 0.607, then bring this one this side into 108 divided by 0.37. 531, that is silver salt of the carboxylic acid. So that organic acid. So this salt is having the 3 silver atoms and 1 organic anion, carboxylate anion. So then it could be Ag3. So 3 into 108 plus A is equals to 531. So A is equals to 531 minus 3 into 108. So A is equals to 531. So this is equals to 324. So this value is equals to 207. So this 207 is actually the mass of A3 minus ion. But organic acid is containing the 3H plus ions also. Along with A3 minus ion, we have to add the 3H plus ions mass. So H3, molecular weight of H3A is equals to A3 minus ion mass plus 3 into mass of the hydrogen, that is 1.008. So 207 plus 3 is equals to 210 grams per mole. So like this we can solve the question. Let us solve some more questions. 27.6 grams of K2CO3 was treated by a series of reagents so that it is converted into the K2ZN3 FeC and taken 6 whole taken twice. Find the mass of this complex. See here they said a series of reagents. Whatever it may be, the beauty of this POAC is we take the starting reactant molecule and the final product only. Whatever the series of reagents or the number of reactions involved, so we don't consider them. Directly we take the product, so that we'll apply the POAC to the reactant and the product, so that we get the directly answer. So here we see that K2CO3 was treated by a series of reagents, finally producing K2ZN3 FeCN taken 6, whole taken twice. Now let us apply the POAC. You can apply the POAC to the potassium, carbon or oxygen. But only thing is, ions whatever are there, ions may move along with other components during the series of reagents unless and until they mention it is conserved. If they say that these metal ions are conserved, then we can take the potassium. If they don't mention the metal ions are conserved, then we have to go for the covalent bonded atoms. So here covalent bonded atom is carbon. So carbon will take. So here we say that carbon is conserved. Then when carbon is conserved, how many moles of carbon is present? Only 1. So 1 into number of moles of K2CO3 is equals to, here 6 into 2, 12. So 12 into number of moles of this complex. I don't want to write down this larger formula, this time writing the complex. So here number of moles, weight is given. Weight is 27.6 divided by its molecular mass is 138 is equals to 12 into, they are asking directly the mass of this one. So weight of the complex divided by molecular mass, that is 697. Straight away we will get the answer. So weight of the complex is equals to, do the cross multiplication, 27.6 into 697 divided by 138 into 12. So let us solve this. 27.6 into 697 into 1 equals to 27.6 into 697 divided by 138 divided by 12. So it is 11.6 grams. So 11.6 grams of the complex is going to produce. Now let us see another reaction. Calculate the mass of CO2 gas produced by combustion of 570 grams of the octane. Octane molecular formula, this one. So that solution, whenever an organic compound undergo combustion excess, so that we get all carbon shall be converted to the carbon dioxide and hydrogen shall be converted into the water. Even though the stoichiometric coefficients are not required for us, we need only the molecular formula of the products. So here we shall write down that carbon is conserved because they are asking about the carbon dioxide. So both sides carbon is present. So C is conserved. Then here, how many carbon atoms are there? 8 are there. 8 into number of moles of the molecule octane, that is C8H18 equals to, here 1 carbon is there, 1 into number of moles of CO2. So here 8 into number of moles means weight by molecular mass. Weight of the octane is given 570 divided by its molecular mass is 104 is equals to number of moles of the carbon dioxide, that is we have to calculate the mass of the carbon dioxide. So weight of the carbon dioxide to be calculated. Molecular mass of the carbon dioxide is 44. So that here weight of carbon dioxide is equals to, do the cross multiplication, 8 into 570 into 44 divided by grams of carbon dioxide is going to produce. Now let us see another question. So it looks like a larger question, but even this type of the larger questions can be solved in a minute of the time. because using the POAC. Let us see what is the question. In a gravimetric determination, the purpose of using the word gravimetric determination is, in gravimetric determination, atoms are conserved. Means whatever the starting reactant molecule we have taken, the same, all the atoms of the reactant molecule shall produce into the various products. That is, whichever is required, that we have to pick up. So here in gravimetric determination, phosphorus, an aqueous solution of NaH2PO4 is treated with a mixture of ammonium and magnesium ions to precipitate. So they have taken the phosphorus. So indirectly they are saying that phosphorus is conserved in the gravimetric analysis. So we have to consider the phosphorus atom. Magnesium ammonium phosphate is produced. This precipitate on heating decomposed to the magnesium pyrophosphate Mg2P2O7, which is weighed. A solution of NaH2PO4 yielded 1.054 grams of Mg2P2O7. What weight of NaH2PO4 was present originally? So let us take here NaH2PO4. It was treated with a series of compounds and finally been converted into the Mg2P2O7. Here phosphorus is conserved, P is conserved. Why phosphorus is conserved? In the gravimetric analysis, they are taking the phosphorus only here. So here, one phosphorus is present. So 1 into number of moles of NaH2PO4 is equals to, here 2 phosphorus are present, 2 into number of moles of Mg2P2O7. So let us take the weight by molecular weight. Weight of this compound NaH2PO4 divided by molecular mass is 120 is equals to 2 into weight of the, see, NaH2PO4 yielded 1.054 grams of this magnesium pyrophosphate. So its mass is 1.054 divided by its molecular mass is 222 grams. So that we can write down that weight of NaH2PO4 is equals to, do the cross multiplication, that is 2 into 1.054 into 120 divided by 222. So the help of the POAC is, even lengthy questions can be easily be converted into the solution in a minute of the time, only if the atoms are conserved. If atoms are not conserved, I mean this concept is not applicable. Let us see one more question. Now let us solve some more easy questions, and it looks like very difficult, but these are easy questions also. Let's begin that solving these questions. See that 25.4 grams of iodine and 14.2 grams of chlorine are made to react completely to yield a mixture of ICl and ICl3. So let's write down the equation for that. I2 plus Cl2, they are made to react completely, and finally giving ICl plus ICl3. Calculate the number of moles of the ICl and ICl3 formed. Molecular masses are given. So let us try to solve. So this question has to be solved because we have to calculate both compounds moles. So one time we have to consider the iodine is conserved. Second time we have to consider the chlorine is conserved. So first I am considering the iodine is conserved. So here 2 atoms are there. So that 2 into number of moles of iodine is equals to, iodine is present in both the compounds. So that everywhere 1 present. So that number of moles of ICl plus number of moles of ICl3. See here 2 into number of moles of iodine means weight by molecular weight. Weight is 25.4 divided by molecular mass is 254. Number of moles of ICl plus number of moles of the ICl3. So it goes 0.1 times, so that this total value, number of moles of ICl plus number of moles of ICl3 value is equals to 0.2. Second time, let us consider the chlorine is conserved. Cl atom is conserved. So here 2 chlorine atoms are there. So 2 into number of moles of chlorine equals to, again chlorine is present in both cases. So in first case only 1 chlorine atom is present. So directly number of moles of the ICl plus. Here 3 chlorine atoms are there. 3 into number of moles of the ICl3. So 2 into number of moles. Weight, how much is given? 14.2. Divided by molecular weight, it is 71, is equals to number of moles of ICl plus 3NiCl3. So this goes 0.2 times. So this value equals to 0.4 number of moles of ICl plus 3 number of moles of ICl3. So now this is equation number 2. Subtract the equation 1 from the equation 2. So here we'll write down that subtract equation 2 from, equation 1 from equation 2. So equation 2 is 0.4 equals to number of moles of ICl plus 3NiCl3 minus, this is 0.2 is equals to number of moles of ICl plus number of moles of ICl3. So here it will be 0.2 value, ICl cancel out. So here it will become 2 into number of moles of ICl3. So it goes 0.1 time. So that number of moles of ICl3 is equals to 0.1. This 0.1 is substituted here or there. So number of moles of ICl3 we got the 0.1. So here 0.2 equals to number of moles of ICl plus number of moles of ICl3 value is 0.1. So that number of moles of ICl is also equals to 0.1. 0.2 minus 0.1. So like this we can calculate these questions even using the POAC simple concept. Now let us see one more question. 1 gram sample of KClO3 was heated under such conditions that a part of it decomposed according to the equations. Here 2 equations they had given. Means complete KClO3 is not decomposing in the first reaction itself. So one part is decomposing into the one type of the products and another part is decomposing into the another type of the product. So the 2 equations we have to consider. See, KClO3 decomposes into KCl plus O2, balancing equation they had given but not required for us. So actually here we have to put this 6, 3 O2. And 4 KClO3 decomposes to 3 KClO4 plus KCl. Even these are not necessary to balance. If the amount of O2 evolved was 146.8 ml at STP, calculate the percentage by weight of KClO4 in the residue. Only residue they are asking, not in the products. So that let us see here, first equation. Let us write down both the equations. KClO3 decomposes to the KCl plus O2. KClO3 decomposes to the KClO4 plus KCl. See, KClO3 present in both cases. So we don't know what is the mass of the KClO3. Let us take the x grams. Here it is equals to y grams. X plus y equals to 1 grams. So now let us see here, apply the POAC to the oxygen. Why? Because oxygen is present here. So 3 into number of moles of KClO3, because oxygen is conserved. Here 2 oxygen atoms, 2 into number of moles of the oxygen. So 3 into weight of KClO3 we don't know. That is weight of KClO3 in this case divided by molecular mass of KClO3 is equals to 122.5. 2 into, see, volume is given 146.8 divided by 22,400 ml STP. Given volume by STP volume gives the number of moles. So weight of KClO3 in this case is equals to, do the cross multiplication, 2 into 146.8 into 122.5 divided by 22,400 into 3. 0.535 grams is given. I shall erase this side because the space is not sufficient for us to solve the rest of the part of the question. See here, KClO3 mass we calculated. Now let us calculate the KCl mass. So weight of KCl we have to calculate. Now potassium is conserved, or else chlorine also can be conserved. So I am considering K is conserved. So now here one potassium is present, 1 into number of moles of KClO3 is equals to 1 into number of moles of KCl. You may ask the question, what is the need to calculate the KCl? Because they asked finally residue. In the residue, oxygen will not present. In residue, KClO4, KCl and KCl will be present, so that we have to calculate the mass of the solid compounds in the residue. Then only percentage can be calculated. Mass of the KCl or KClO4 divided by total mass of all the compounds. So number of moles of KClO3, weight, here we have done 0.535 grams is involved. 0.535 grams divided by its molecular mass 122.5 is equals to weight of KCl that has to be calculated, and molecular mass of the KCl. See, atomic mass of the potassium is 39, whereas chlorine is 35.5. So we get the 74.5. Then weight of KCl is equals to, do the cross multiplication, 0.535 into 74.5 divided by 0.325 grams is the weight of KCl in the first equation. Now let's come to the second equation. Here let us make the oxygen again conserved, because we have to calculate the KClO4, so that O is conserved. Here 3 oxygen atoms are 3 into number of moles of KClO3 is equals to 4 oxygen atoms are present, 4 into number of moles of KClO4. So 3 into weight of KClO3 involved in this process. See here they are asking about the weight of KClO4. Already weight of the KClO3 we calculated here. So remaining weight is participating here. So weight of the KClO3 equals to 1 minus 0.535, because total mass of the KClO3 was 1 gram only. Divided by its molecular mass 122.5, 4 into weight of KClO4 divided by molecular mass of KClO4 138.5. So that weight of KClO4 is equals to, do the cross multiplication, 3 into 138.5 into cross multiplication 0.465 divided by 4 into 122.5. 0.394 grams of KClO4 was produced. Now let us calculate what is the KCl going to produce. Very simple, that in the second equation, mass of Y, that is KClO3, is equals to 0.465 grams involved. 0.465 grams involved. KClO4 produced is equals to 0.394. 0.394 grams formed. Remaining is the mass of the KCl in the second equation. So that is 0.465 minus 0.394. This is equals to 0.071, because both are solid substances only. So now percentage of KClO4 is equals to mass of KClO4 divided by mass of KClO4 plus mass of KCl produced in the first equation plus mass of KCl produced in the second equation. Mass of KClO4 was 0.394 divided by 0.394 plus mass of KCl produced in the first equation was 0.325. 0.325 plus mass of KCl produced in the second equation is 0.071. Percentage they are asking, so that it has to be multiplied with 100. So now let us see 0.394 into 100 divided by 0.79. 49.87% is present. So like this we can solve the POAC. I hope you understand today's class. If you understand this, please do share with your friends and like the videos. If you have any doubt, please do send your doubts to the classroom point @gmail.com, and don't forget to subscribe the channel. Thank you one and all.